vector geometries, that is basically the toughest part of vectors, right? Because this is like a combination for all the things we have seen so far. In addition, over here we are going to learn about parallel vector, collinears, and 3 points connecting, three or multiple points connecting a straight line. Now again in this part, like all the three words that I've said so far, parallel vectors connecting the points to create a straight line, and collinears, they have the same type of working, but they are already like always approached with these three different names. And another thing over here, we'll come across unknown ratios of two vectors, that is usually referred to using these constants as mu and lambda. Okay, this is lambda and this is mu. So we'll start. We'll start with the first one. I think we have over here 5 to 6 questions for vector geometry. This is the first one, which is quite easy, taken from June 2019 paper 1. So we'll start. So we have a triangle over here, that is obviously our regular geometrical shape, and it says the diagram shows triangle OXY where OX is 2A plus 3B and OY is minus 3A plus 5B. So over here the A and B that are written in as a part of the vector, these actually represent the directions. Now, as you can see that these vectors are not exactly in the vertical plane or in the horizontal plane, right? So they are like somewhere in between the vertical and horizontal plane. That's why the directions are referred as a combinations for vertical and horizontal plane, where usually A represents the vertical plane and B represents the horizontal plane, right? Again, when you are supposed to write these plane directions A and B, as you can see over here they are written in bold. You cannot write in bold, right? So what you can do is that you can write this small a and write in hat over here. The hat over here represents the direction that A is directing, from this direction to that direction or something like this. So the hat and on top of those directions on top of those small alphabets indicates the directions of those. Okay, I hope it will get much more clear as we go along. So let's start. Now, they have provided you with OX and OY, and in part A, they are asking you that find and simplify an expression in terms of A and B for YX. Now, we're obviously going to use the triangular method over here, right? In order to solve the YX, I can just draw over here that these are the actual directions. Yx is equals to Ox. That means clearly indicating that Oy and Yx are traveling in the same direction, whereas Ox was in the opposite direction. So we can start that. I'll first write down the formula over here, that Oy plus Yx is equals to Ox, which means that if I just make Ox the subject, that will be Ox minus Oy. So OX over here is 2A plus 3B, and so this is OX, and OY was minus 3A plus 5B. Now you can just add the coefficients of A and B together. You have 2 minus 3, which is basically going to be added together, and then you're going to be left with 2 plus 3, that's 5. Right, so you have 5A and 3 minus 5. This over here is going to be a negative 5 because minus plus will eventually create minus. So 3 minus 5 is going to be like minus 2. Right? So sorry, yeah, minus 2, right? So 5A minus 2B, and that is the final answer for your YX vector, right? So we can write that. We just have to write this in the given space also. So I'll just write it in a very small pattern over here. Yx 5a minus 2b. Right? And that is the final answer for your vector Yx. I hope that was clear for everyone to understand. We'll be moving on to the next part. The point z on yz is such that OZ is minus 2 by 9a and 35 by 9b. Calculate, if in its simplest form, the ratio of yz and zx. Now over here we already have the total length for yx, right? But we do not know that at what ratio that this point z is situated, because it is somewhere in middle of that point y and x, but we don't know the ratio, so we need to find out that ratio. And before we can find out that ratio, they have also provided with one different vector. That is, if you connect this point O and Z together, then you get the vector OZ, which is minus 2 by 9A and 35 by 9B. So I'll just write those in the diagram over here. Minus 2 by 9A plus 35 by 9B. Okay, now another part very important is that we are trying to find out, like, both yz and zx, right? As the question was asking you to find out the ratio in between these lines, we first have to find out the separate vectors of this line and then find out the ratios. So in order to find out that yz over here, which is basically traveling in this direction, right? Yz is only focusing on oyz. I'll just highlight the part. This is OYZ, right? We can clearly see OY, YZ are in the same direction, whereas OZ was in the different direction. So obviously it's going to look like that we are in part B. Okay, this is for part B. OY plus YZ is equals to going to be OZ. So YZ is going to be OZ minus OY. Okay. So for yz, now we have to find out the yz vector, which is going to be OZ was minus 2 by 9a plus 35 by 9b. And OY was minus 3a plus 5b. Now again, if you add, like if you have to add, have this minus in front, that minus will be multiplied with the all vector of OY, right? So in that case, 3 minus 3a would be positive 3a and 5a would be negative 5a. So I don't have much space, so I'll just move down. Okay, so this is it. So now we have minus 3a plus 5b, which is going to be minus 2 by 9 plus 3, minus 2 by 9 plus 3, that is 25 by 9. 25 by 9a, and then you have 35 by 9 minus 5, so you get minus 10 by 9. Right, I'm obviously adding the b and a together with each other, and this is what the final vector for yz would look like. So we have the final vector for yz, and now we'll be moving on to find out the final vector for zx. I'll just shift this a little bit to the right so that everything is quite linear. Okay, so we'll be moving on to zx. For zx, I'm going to highlight a different section of the journey of the triangle, that is from this part. Right, OZX. The blue portion of the part will be now examined to, or will be now used to find out the vector for ZX, right? So we will move, we're still in part B. So now again we have OZ and ZX are in the same direction and OX is in the different direction, right? So we can write OZ plus ZX is equals to OX. So ZX in that case would be OX minus OZ. OX was 2a plus 3b, right? So you have ZX as 2a plus 3b, and again minus of the 2 by 9, 35 by 9 would be minus, it will be positive then because you already have a minus in front, right? So positive 2 by 9a and negative 35 by 9b. Then you can just, like arrange, add the values of a and b together. 2 plus 2 by 9. 2 plus 2 by 9, it's going to be 20 by 9 a, and 3 minus 35 by 9, that's going to be minus 8 over 9 b, right? So we have the final coordinate or final vector for your zx also. Okay, so now we'll be moving on to the final stage where we are trying to find out the ratio for these two vectors, right? In order to find out the ratio, I'll first try to add one more line in order to simplify the vectors. For example, for this yz, okay, this, since I'm adding one more line, so I'll just write it over like this. For yz, I can take 5 by 9 as a common, right? Because both 5 is a common factor for 25 and 10, and 9 is the denominator for both the fractions. So I can write 5 by 9, and that would be 5a minus 2b. And again, I can take for zx over here, I can take 4 by 9, which is going to be 5a minus 2b. Okay, so lastly, for the last step, in order to find out, since they're talking about or they're asking for this yz equals to zx, right? That means yz would be like whenever they try to find out the ratio, you always do you always fraction those ratios together first. You always divide those ratios first, and then you find out the fractions over here. So for yz is to zx, in that case, you're going to divide yz divide by zx, which is going to be 5 by 9. So revise it was, yeah, 5 by 9, 5a minus 2b divided by 4 by 9, 5a minus 2b, which you can clearly understand this 5a minus 2b would be cancelled each other out, and you're left out with 5 by 9 divided by 4 by 9. So if you just take that entirely into a calculator, your final answer would look like 4 by 9. Your final answer would look like 5 by 4 in that case, right? So finally you can write yz is to zx, that would be 5 is to 4. Yeah, 5 is to 4. Right, so this is the final answer for your ratio type of maths, right? Whenever they talk about that if these two lines are parallel to each other, or if these two lines would create a straight line, or if they are collinears in a straight line, or if they are, even if they want to find out the ratios, this is how you do the work. I will give the list over here for what kind of wordings you're supposed to do this kind of working. First one is if they consider these two lines are parallel or not. So parallel lines, if they're collinears. Now remember, collinears basically indicate that when you like, for example, the question might sound like that there are 3 points A, B, C, and you have to prove that if A, B, C are going to be collinears or not. By collinears, they actually indicate that if you're going to connect those 3 lines, 3 points A, B, C, and if they're going to create a straight line or not, right? So if they turn out to be have a similarity in between their vectors, or you have like you're able to find out a ratio for those vector. In that case, you can say that since these two separate vectors have a certain ratio in between them, that's why we can conclude that these 3 points would be collinears, or would create straight line, or would be parallel to each other, or eventually you can also find out their ratios if they're directly asking you for the ratio then, right? So we can write parallel lines, collinears, or for straight lines, right? I mean, asking about the ratio would be the direct working, right? Direct wording that they're directly asking about the ratio. But instead of directly asking about the ratio, they can use these 3 different words. If the lines are parallel, if the lines are collinear, if that line is a straight or not, right? So these are the different wording that they can use in order to identify, or in order to make you find out the ratios for those points or lines. Okay, so that was it. We will be moving on to the next question, question 7. Okay, question 7, again, you have a big triangle over here. It states that figure 1, where this is from June 2022, paper 2. It says that figure 1 shows a quadrilateral ABCD such that AB is A and AD is B. Okay, so this is A and AD is B over here. This is A and AD is B over here. Okay. And it also says that A is the point such that ADE and BCE are straight lines. Now this point over here is going to be a very important part in the in the upcoming questions for this part. So I'll just highlight it. Okay, so we'll move on. They've also provided us with information that BC is equal to this vector. We need to show that AB is parallel to DC. Okay, now we have a length for BC over here, right? We have a vector for BC, which is B minus 1 by 3A. And problem is, we're not concerned about BC. We're concerned about the proving the fact that AB is parallel to DC. So which means that we have to calculate DC, right? But problem DC, like if I have to connect a triangle over here or straight line AC, DC is only connected to these 2 points, right? ADC. In order to find out DC, I should have the vector for AC. So in order to find out the vector, I need to use ABBC to find out AC, and then AC and AD to find out DC. And finally, after finding out the vector DC, I can clearly say that if they're going to get ratio, like if they're going to create ratios or not. If they do create ratios, then only I can finally conclude that they are indeed parallel. So for the first case, at first we have to find out the vector for AC, which is going to be AB plus BC, right? How much space do we have? Okay, we have a lot of space. So let's start for AC, right? AC is going to be AB plus BC, which means AC is going to be AB was already A and BC was B minus 1 by 3A, right? So A plus B minus 1 by 3A. 1 minus 1 by 3 is 2 by 3, I guess. Yeah, 2 by 3. 2 by 3B. Right, so we have the length for AC, and now we'll be moving on to calculate the length for DC. So I'll just first use this and shift it to the right a little bit, and then I'll do the calculations for DC. For DC, we have this triangle ADC where AD and DC is in the same direction and AC is in the opposite direction. So it would look like that AD plus DC is equals to AC. Finally, DC is going to be AC minus AD. So DC is basically AC over here was already 2 by 3A plus B. So 2 by 3A plus B minus AD was just B, right? Yeah, minus B, which we can clearly understand the B would get cancelled with each other because you have plus B and minus B. Finally, you are left out with DC as 2 by 3A. Sorry. 2 by 3A. I'll just quickly cut this over here and move it to the bottom space. This is quite right. Now over here, since you get DC as 2 by 3A, what was the value for AB? AB was just A, right? So you can write instead of, I can just write it over here at the very top. AB was just A vector. That means instead of writing this A, what I can write in the next line is that DC is equals to 2 by 3 AB, right? Because AB was the value for A, or A, instead of writing A, we can write AB vector. So as I've already stated at the very start, that if two lines that they have this constant ratios in between them, like 2 by 3, 5 by 4, these are like constant ratios. If two lines have this kind of ratios, we are going to conclude that these two lines are parallel, collinears, or create a straight line. Or if they directly ask you to find out the ratios, these are the ratios then, right? I can already understand that DC is 2 by 3 third of AB, or you can also say that DC is to AB would be 2 is to 3, right? So we can finally conclude that therefore, right, yeah, DC is parallel to AB, right? So final conclusion over here would be DC parallel to AB. And if you find out the ratio, that's going to be DC is to AB, that's going to be 2 by 3. So 2 is to 3. And if you guys are having a hard time to understand that how I found out the ratios, this is multiplied to the fraction. You take this to the left hand side, it will be divided. DC over AB is equals to 2 over 3. So DC, well, corresponding ratio for DC would be 2 and corresponding ratio for AB would be 3, right? So that's why this is how they would look like if you would write this statement in terms of ratio. That was it for the part A. I hope it was clear for all of you. We'll be moving on to part B. For part B, it says that given that lambda is a scalar and such that BE is lambda B minus A. Okay, and over here lambda is a scalar. We need to find out the value for that lambda. Okay, now BE, right? Okay. BE was for this total length of this triangle. We do have the vector for BC though. Right, yeah, BC is over here. This is the vector for BC. But wait, we have to calculate the value for lambda and they're just giving you 2 marks. Okay, I think that's quite a lot less mark over here because in order to find out lambda, we have to actually, do a lot of things and we have to consider the lambda and mu in this case, right? So we'll first start. I am trying to find out BE, right? Because BE, like the value of BE contains that lambda. So whenever that one length has the one vector has that, constant involved with it, you have to find out two equations for that length. Now, already we have one equation that BE is lambda B minus A. And they also gave you another equation over here that was that BCE are straight lines, right? So you can certainly consider that whenever 3 points create a straight line, they always have the same kind of fractions over here. For example, over here in this case, what you can do is that BE, right? I can actually express BE in terms of BC since I already know they are going to create a straight line, which was already stated in the question. So I can write that BE is equals to BC, but there must be some ratio in between them, right? They're not exactly equal. There's some kind of ratio in between them. But as I'm not aware of the ratio, so I can write mu. This constant, unknown constant over here represents the ratio in between the line BC and BE. So I'll just try to figure out the one another equation for BE in terms of mu over here. So I'll just write the value for BC. The value for BC was B minus 1 by 3A minus 1 by 3A, which is going to be mu B minus 1 by 3 mu A. Okay. So now we already have two different equations. This was the second equation that we calculated for the length of BE. The first equation was already given in the question, that lambda B minus A. So I'll just write it down over here. The first equation for BE was lambda B minus A. This was the first equation. And this was the second equation. Now always remember that these two equations represent only one vector, right? That means if we have the value for lambda and mu, and if we simplify these two expressions, they would eventually lead up to one value because they are already directing to one specific vector. So what I can do is that I can just write BE in terms of like BE is equals to BE because they are of same vector over here. So finally I can write BE is equals to BE, and that's going to be lambda B minus A is equals to mu B minus 1 by 3 mu A. At this part, after done writing the equations at two sides of the part, I'll start comparing from them by obviously comparing the A coefficients with A coefficients and B coefficients with B coefficients, right? So you have A coefficients, which is going to be minus 1 equals to minus 1 by 3 mu, which basically finally says that mu is going to be minus 1 over minus 1 by 3. That's going to be positive 3, right? So the value for mu is positive 3. And again, if I have to compare the coefficients of lambda for b over here, the coefficients of b only have lambda and mu. So you get lambda equals to mu. We already have the value of mu, that is 3. So you get the value of lambda also as 3, right? In part B, they were only interested about calculating the value of lambda, and that's what we did, right? So there's nothing else to work over here for this part. That was the end for part B, and we calculated the value for lambda, which is 3 over here. Okay, then we'll be moving on to part C. For part C, it says that the area of the triangle ABE is x square meters, and given that the area of the quadrilateral ABCD is p square meters, we need to find an expression for p in terms of x. Okay, so basically we have to express the area of the quadrilateral in terms of x, right? So I'll just remove all the things over here because these are not needed anymore. They have already provided you with the value of the area of ABE, that is for the bigger triangle, right? I'll just highlight. This is the bigger triangle that I'm talking about, and they've already given you the area for the bigger triangle, which is x. Now we do not have any value for that smaller triangle in between, DCE. Without DCE, we cannot find out any expression for that ABC, because if you focus over here, big triangle minus the small triangle will give you the value for this space, this quadrilateral that we are actually trying to find out an expression in terms of x, right? So I'll first just try to find out that this area of the smaller triangle DCE. There's one similarity over here is that DC and AB, they were parallel to each other, where AB was just A and this was 2 by 3A, right? That means obviously the ratio was 2 by 3 or 2 is to 3. I can use similarity over here. For similarity, I always try to use, the triangle whose area I'm trying to find out, I'll always put that at the numerator, right? That is the formula for similarities. So we can write triangle DCE over triangle ABE is equals to DC over AB, right? Which is going to be triangle DCE divided by x, because you already know the area for the triangle ABE was x. I'll not write that x at the denominator. I'll just take that and write it on the other hand side. But then again, for area, it should be a square, right? Length square or ratio square. So you get, sorry, DC was 2 by 3a, and this was only a whole square multiplied with x. Obviously, the a would cancel out each other. Finally, you're left out with triangle DCE is going to be 4 by 9, right? 2 square is 4, 3 square is 9. So 4 over 9x. This is the final value for triangle DCE. Yeah, then we can do one thing is that we'll find another expression for the quadrilateral ABCD, that is by subtracting DCE from the big triangle ABE. So I'll just write that down in the bottom space. Right, and for the last part over here, I'll try to find out quadrilateral. I'll just write quad over here, quad ABCD. That's going to be triangle ABE minus triangle DCE, which is going to be ABE is just x minus 4 by 9x, and that's going to be 5 by 9x, right? So this is the final expression for the quadrilateral P in terms of x, because we already know the area for the quadrilateral was P, so in that case, P would be equals to 5 over 9x, and that is the final value for P that we can write in terms of x, right? So that was it. Just this much is enough for the working of part C. So I hope this was clear for everyone to understand the working for how to find out area. Like in vector, we cannot actually calculate area unless they give you the modulus of those alphabet A and B, right? But without the modulus, this is how you're supposed to approach with the questions. You use similarity always in order to find out the corresponding area for the other unknown triangle or structure that you have. Okay, so this is it for this question. There was no other part of it. I hope it was clear for all of you. We'll be moving on to the next one then. Okay, so this one, it looks a little bit tricky, right? Because you have this circle inside a triangle. Sorry, a triangle inside a circle. So we'll start question 9. This is again from June 22, paper 2R. We have this figure 3 shows 3 points A, B, and C on a circle with center O, where AOB is a diameter. Okay, now again, one thing about diameter is that AOB is a diameter. This also indicates that AOB is a straight line. AOB are collinears, right? Of the circle. D is the point on AC such that AD/DC is 3 is to 1. I already know the ratio for this, that AD is 3 portions and DC is 2 portions of AC, right? So this is 3 and this is 2. And that in that case, the ratio for AC for the total length would be 3 plus 2, 5. And we also have the vectors OA as A, AD as AD. Okay, AD as B. Okay then. So this is A, sorry, wrong direction. OA, this is A, and AD from A to D, this is small b, right? Yeah. And we need to find out AC in terms of AB, CO, and DB. Okay, so we'll first start with AC. Since we already have the value for AD, I'll just use a straight line over here to represent the data over here. A, this is where D is, and this is where C is, right? We already have the ratio 2 is to 3 over here, and we're trying to find out the total ratio using the corresponding of AD only. So I'm going to write AC is to AD, as AC over here represents the total length. It's going to be the summation of the corresponding fractions. 2 plus 5, 2 plus 3 is going to be 5. So we have 5 is to, for ratio of AD was, that's 3, right? You can obviously write this as fractions. That's going to be AC over AD is equals to 5 over 3. Now AD was just B over there, right? So you can just take that AD and write it to the left hand side, to the right hand side. So that would be AC equals to 5 by 3 multiplied with B. Right, yeah, that is it. We have calculated the length for AC vector, and this straight line that I've drawn over here is not obviously a compulsory part, but it's just there, good for the explanation for me. Right, so just cut it and write it at the very bottom. Okay. So this was for part A1. Right, for part A2, they have CO over here that you want to calculate for CO, right? Now you have to understand that your entire vector starts from O, right? OA, AC, and CO. Obviously now over here, all the three lines are actually traveling in the same direction, right? OA, AC, and CO. So if all the lines are traveling in the same direction, that means summation of all these three vectors would be equals to 0. So we can write like this, that OA plus AC plus CO equals to 0, and I'll just keep CO on the left hand side and write all the others to the right hand side, or take all the others to the right hand side. So it's going to be negative AC and negative OA. Negative AC was that we calculated over here, that was minus 5 by 3b. So we have minus 5 by 3b, and OA was just A, right? So we have this as the final vector for the vector CO, and this was also the working for part 2. I'll just keep it over here again. Okay, so we'll be moving on to part 3, where they're asking about the length of the vector dB. For dB again, you have to consider it like this. If I just erase all these things, if OA was A, in that case BO would be another A, right? Because AOB was a diameter. In that case, OA would represent to be the radius. So each radius are of equal length, obviously. So OA and OB or BO, OA and BO would be of equal vectors. In that case, BA is actually 2A, AC is already known, so you can easily find out, oh wait, Yeah, right. You have the length for BA, and then AD is already known. That was just A. And you can use these to find out DB. Again, like the similar one, A part 2, all the three vectors over here are again in the same direction, right? So that means all of the three vectors would be equal to 1. I'll just first write one thing over here just for the explanation purpose, that OA is equals to BO is equals to vector A, which means that BA, that is going to be 2A in this case. Finally, for the last part, I'll just rearrange the formula. That is going to be BA plus AD plus DB is going to be 0. So DB is going to be minus AD minus BA again. Right, minus AD is what? Minus AD was just minus A, and minus BA is minus 2. Sorry. Oh, wait, sorry. This was supposed to be B, right? The value for AD was B, not A. Right, in that case, you have this minus B in front and negative 2A. Right, so this is the length for DB. I hope this is clear. We'll be moving on to the next part. Right, so that is it for part 3. I'll just cut this and paste it over here again. I'm quite sure I don't have much space for it over here, so I'll just write it like this in this space, right? Right, so this is for A part 3, right? So in this space you can find all the three vectors for A part 3, A part 2, and A part 1. We'll be moving on for part B, but before part B, we have these two statements that need to be considered. Now it says that point E is the point, just one minute. So, okay, it says that point E is such that CEO and DEB are straight lines over here. So if I go back to the diagram, I'll just erase all the things over here. That point was saying that C, E, O, and D, E, B, these lines are straight over here. And by considering AD plus DE and AC plus CE, find a simplified expression for AE in terms of A and B, which means that we have to use these two different combinations to find out AE, right? Like this one would give you one equation for AE, and this one would again give you one equation for AE, and finally we have to again do the similar kind of working we did for the previous one. You compare the two equations and then find out the value for lambda and mu. So let's start. We'll start with AD plus DE, right? So for AD plus AD plus DE, if I connect the line over here for AE, this is how the line would look. We are only focusing on this one. Problem is we have the value for AD, but we do not have any length for DE. But as DE lie on the straight line DB, which means that we can find out some kind of statement for DE in terms of DB, but there will be an unknown ratio. So I'll just first write over here that DE. The line also went. DEB is a straight line that was already given into the question. I'm just going to write at this at the very top so that I can refer to this statement later when I have to revise or recheck, right? So DEB is a straight line, which means that DE is going to be mu DB. Now we already calculated length for DB in part A3, which was minus B minus 2A, so it's going to be minus mu B minus 2 mu A, right? And again after this we can start with we can now find out one expression for AE by connecting AD and DE together. So you have AE is equals to AD plus DE. AD was just B and DE is mu, sorry, we can write plus minus together. So it's just going to be negative over here, right? So minus mu B minus 2 mu A. What I can write is that I can just connect the b together and take b as a common factor from this, which is going to be minus 1 minus mu b minus 2 mu a. So this is the final vector for AE. This is not in terms of AB, right? This is in terms of mu A and B. So this is like the first expression for A. I will use it obviously, but then before that we'll move on to the second part. In the second part, they're also talking about we have to use AC and CE, which is basically using the concept CEO is a straight line this time. So we will start again that CEO is a straight line, which means that CE is equals to lambda times CO, right? And then again for CO, the value for CO we calculated was minus 5 by 3b minus A. So you have lambda, I can just write directly minus 5 by 3 lambda b minus lambda a. So it's going to be minus 5 by 3 lambda b minus lambda a. Okay, so we have the value for CE now. Now again, I can focus on this part of the triangle, AC, CE, and AE, right? That would also give you a value of the vector AE in a different format. So we can write AE is equals to AC plus CE, which is basically AC was already we calculated. That was 5 by 3b, so it's going to be 5 by 3b, and CE is minus 5 by 3 lambda b minus lambda a. And finally we can do the same working that as we did for the other AE. We can take b as a common factor, so it's going to be minus 5 by 3 minus, let's see, 5 by 3 minus 5 by 3 lambda b minus lambda a. Okay, so now we have the two expressions for AE. I will just first put it in a more organized part in the very end part, and then we'll start doing the other parts of this. Okay, so this is the second equation now, right? So after this, we are obviously going to write AE is equals to AE, and this is how the expression would look like. AE equals to AE. For this AE, we have 1 minus mu B minus 2 mu A. And for this part, we have 5 by 3 minus 5 by 3 lambda B minus lambda A. Right? Okay, so now we'll start the comparing. And by comparing the A coefficients, we have minus 2 mu is equals to minus lambda, which basically gives you an expression for lambda, that is 2 mu, right? Because a minus gets cancelled out. And again, if we move on to part B again, we have 1 minus mu is equals to 5 over 3 minus 5 over 3 lambda, right? Yeah, okay. So again, this would mean that you can just input that the value for lambda over here. So you have 1 minus mu 5 by 3 minus 5 by 3 2 mu, which is going to be what, 10 by mu, right? 5 by 3, so 5 by 3 multiplied with 2 is 10 by 3, right? So sorry, I'll just write all the mu together and all the numbers together. So you have 10 by 3 mu minus mu 5 by 3 minus 1. So that's 10 by 3 minus 1 is 7 by 3 mu, and this is 5 by 3 minus 1 is, wait, sorry, 5 by 3 minus 1 is 2 by 3, okay. So this is 2 by 3. Finally, you can write mu is equals to 2 by 3 over 7 by 3, and write this exactly on a calculator like this: 2 by 3 divided by 7 by 3, which is going to be 2 by 7. So for mu, the value is 2 by 7, and you can use this to find out the value for lambda, which is going to be 2 by 7, that is finally going to be 4 by 7. So in that case, lambda is 4 by 7 and mu is 2 by 7. But the problem is the question over here was not asking about lambda and mu. The question was asking about to find out the length of A in terms of A and B only, right? So since we already have the value for lambda and mu, we can just use those values and input it in any of the equations 1 and 2 for AE and find out the final value for AE. I'm going to choose this equation 1 over here, 1 minus mu B minus 2B, because it's less complicated. So I think I need to shrink this a little bit more. So sorry for this, just give me 1 minute. Okay, so we'll start the other parts from here, from this given space, because I can see the another question would start from the next page, right? So we would not have much space. So we're continuing part B. So AE in that case would be 1 minus 2 by 7, right? Yeah, 1 minus 2 by 7B minus 2 by 7A, which is basically minus 4 by 7A. That is again plus 5 by 7B. And this is the final expression for AE that we were trying to calculate, that was asked to calculate in part B originally. Right. Okay, so that was the entire working for just part B. I hope all of this was clear for every one of you to understand this part. We'll be then moving on to the we'll be then moving on to the next part. Last part where it says that a vector, right, you can see over here, I guess a vector is, the modulus of a vector is a and the modulus of b vector is 6. We need to calculate the exact area of the triangle ABCD. Now if we go over here, and they have already provided with vector a as 7 and b as 6, in that case we are only focused on ABC, right? Now again, this part is not needed, right? A is this time over here is out of concern. Now we can use basic geometry over here also. That's because if this is the diameter, right, opposite of diameter is angle C, and angle C is going to be 90 degree. If angle C is 90 degree, then it would indicate that AC and CB are basically the height of the triangle. So we can use the formula half into base into height to find out the area of this triangle ABC. But problem is that we have the length for BA, we have the length for AC, but we do not have the length for BC, right? We can use Pythagoras for it certainly. So let's just first find out the length of AC. For AC, it's going to be 5 by 3 B, and B was 6, right? Yeah, 5 by 3 B, and we can finally write 5 by 3 multiplied with 6, so you get 10 over here. So the modulus of AC would be 10. We can do the same calculations for BA. BA was 7 and A would represent, B is 2A and A would represent 7, right? So we can write BA is 2A, which is basically BA is going to be 2 multiplied with 7. That's going to be 14, right? So then we can use Pythagoras from here. That is going to be like, AC plus BC square is equals to AB square. So in that case, BC would be AB square minus BC square under a root, which indicates that BC is going to be 14 square minus 10 square under a root. That is 4 root 6. So you have BC as 4 root 6. Final answer of BC is going to be 4 root 6. Okay, now after this, we still have not found the area for the triangle. Now we can find out the area of the triangle. That's going to be half into base into height. We have the height as 10 over here. AC was the height, and this BC is the base over here, right? So in that case, its area is half into base into height. So area of triangle ABC is going to be half into AC into BC. That's going to be half into 10 multiplied with 4 root 6, which is half 10 4 root 6, and that is 20 root 2. Right, this is centimeter square as a final answer. So this one is part C. I don't think I can fit it in anywhere over here. Right, I highly doubt I can fit it anywhere. Wait just 1 minute. Okay, so I think this is enough spacing for all of you to understand that which part is part C. Okay, yeah, so this is it. All the working for this question is done. We have completed part A, B, C. I'll just go over the questions for the one last time and direct you to the point. This is part A, part A1, A2, part A3, and all these parts are actually part B, right? And this portion over here is only part C. So I hope this question was clear to every one of you, and I hope there's no question. Even if there is, you can obviously reach out to me by writing your questions in the comment sections. So we'll be moving on to the next question over here. This is another question. It doesn't have any sections I can see, but it would look tricky. So yeah, this is again from Jan 2022 to PR. So let's start. We have a parallelogram, as we can see. So over here it says that figure 1 shows a trapezium OABC. OABC, this one they're talking about. in which OA is parallel to BC, and they actually haven't given you any kind of ratios for like any kind of values for OA and BC, but they have provided you with the ratio that OA is to BC is 2 is to 1, and again the point P lies on AC such that AP and PC is 3 is to 1. Okay, so maybe over here somewhere this point P would be present, and AP is 3 and PC is 1, right? And again after this, that is not the end. The point D is on such that OD is lambda OP, and again lambda is greater than 1, and also it means that also it has this point that such that BCD is a straight line. So point D is like in between two parts. It's going to be a part of OP and also a part of BC. It's going to be part like on OP, like on the line OP, but it will also going to be a line that if you connect BC together and if you connect BCD together, is going to create a straight line. So at first, we'll first try to focus out how OP would look like. This is how OP would look like. But again, if you connect BC and if you extend it over here, you can clearly see that that OD would not be inside the parallelogram. It will not be inside over here. But if we can extend this through, and we can clearly understand that this is the point where OP and BC would mean. So what they actually mean is that if you extend the line OP and extend the line BC, the point that these two lines are going to intersect, that's the position for D over here, right? That is the position for D. And finally, you have been given with vectors OA and OB as 6A and 8B. So we have to use different vectors, write our answers in A and B for the vector AD. Okay. So this one they're talking about for vector AD, right? Wait, sorry. Okay, so this is the vector AD they're talking about. OA and AD. You can certainly find out one expression for AD using OA, AD, and OD, right? But problem is you do not have any value for OD. And then again, to find out a value for OD, you have to find a value for OP because OD was related to OP and we do not have any proper fraction for that also. And again, for OP, you have to start finding out AP. For AP is related to AC, and AC is related to BC over here, right? So at the very base, we have to first start with just BC. First, try to find out the value for BC. We already have the ratio OB and BC is 2 is to 1. As we're trying to find out BC, I'll write down the ratio like this. That BC is to OA. That's going to be 1 is to 2, right? And then I can just write this as fractions. OA 1 is to 2. OA was already what 6A, right? So we can just write BC, like make BC common subject over here multiplied with 6A, which is going to be BC as 3A. Okay, so this is the final part, BC as the value for BC as 3A. We're going to use it again to find out the value for AC. I'll just connect the lines over here for AC so that it just looks more understandable, I think. And now we have OB and BC, and we can obviously add those together to find out a vector for AC, right? So it's going to be AC is equals to OB plus BC. OB was 8B and OB was 8B and BC was 3A. So you have 8B, so OB and BC, yeah, okay, then plus 3A. So you have a length for AC again. Now using this AC, you can find, sorry, this is actually OC that we calculated. Sorry, I made a mistake. We were talking about OC all this time, right? As you can see from the diagram, this is the length that we calculated. This is OC. Now using OC and OA, we can now find out AC. So I'll just write it, like shift it over here and write it like this. That in order to find out AC, it's actually OA and AC in the same direction and OC in the opposite direction. So you have OA plus AC. is equals to OC, which means that AC is going to be OC minus OA, right? So OC was 8B plus 3A, and OA was 6A, right? So it's going to be negative 6A. So finally, we're left out with 8B minus 3A. Okay, so now we have another expression for AC. After that, we'll find out an expression for AP, as we already have the ratio for AP is to AC. Now I'll draw a straight line to just clearly explain the ratio concept again. We have A over here. This is point B. This is point C. AP is 3. PC is 1, which means that if you want to find out AP, since we have the value for AC, I can write the ratios like this, that AP is to AC is going to be 3 is to 4, right? Because you are using AC as a whole. That is going to be the summation for the ratios AP is to PC. So 3 plus 4 for the total length, the ratio would be 4. So we'll move on. We can write AP divided by AC is equals to 3 by 4, where AC was 8B minus 3A. Finally, you can write AP as 3 by 4 multiplied with 8B minus 3A, which was the length for AP. That's it. I'll just first rearrange all these parts over here in the given space, and then we will start. Yeah, after we found out BC, we calculated OC. Sorry. Right, and then again from using OC, we calculated AC. Right, and after this, from using OC, we calculated AP. So I'll just write it down over here, and then we'll move on. Another thing, you can just keep the expression for AP like this, or you can obviously break it and write it in a more simplified way, which is going to be what? 6 by 4 or 3 by 4 into 8. 3 by 4 into 8 is going to be 6A, and that's going to be 9 by 4, right? So I'll just keep it like this because I do not have much space over here also. So we have calculated the length for AP, right? So you can use it and find out the length for OP over here, because OA and AP is equals to OP, right? So OD was also a part of OP, so it's very crucial to find out OP over here. So OP, before that, I just want to start with, right, before that, I just want to start with the length of AP again for the last time. AP was actually 6B minus, wait just 1 minute, 6B minus 9 by 3A, so 9 by 4A, right? And now using this, I can find out OP. OP is going to be OA plus AP. OA is 6A plus 6B minus 9 by 4A, which means that 6 plus 9 by 4 is, so 6 minus 9 by 4 is 15 by 4A plus 6B. So this is OP. Okay. Now we have an expression for OP which we can use to find out an expression for OD. So I'll just sorry, I'll just write it down over here. OD was already given in the question, that lambda OP. So we can finally write it's going to be 15 by 4 lambda A plus 6 lambda B, right? So this is OD. The final length for OD is found out. Now using OD and OA, we can find out the first expression for AD, which is going to be OA AD is equals to OD, right? So I'll just write it down over here and then we'll move on. We can write OA plus AD, that is going to be equals to OD. Right, so over here you have AD as OD minus OA. So AD is going to be, OD was 15 by 4 lambda A plus 6 lambda B, and OA was minus A just, right? So you can finally write it down as 15 by 4 lambda minus 6A plus 6 lambda B. Okay, so this is the first expression for AD. So we'll have to arrange it more clearly in the given space over there. So we'll move on to this space, right? Okay, so this one is the first expression for AD vector. Now the second expression for AD vector we can find out. First one we found out using that OAD triangle, right? The second one we can find out using the triangle sorry, not O. We can find out using ACD, this one triangle. Now we already have the vector AC. We calculated that over here, which was 8b minus 3a, and we can clearly see that, as BCD is a straight line, which means that CD would be something related to BC. So it might be like, mu times BC or something. Since lambda is already being used, so we can obviously use mu over here. So we can write, we're using the concept BCD is a straight line. Okay, BCD is a straight line, which means that we can write CD mu times BC. The length of BC was, we calculated 3a, so it's going to be just CD mu, sorry, 3 mu a. Okay, so since we have the length for AC and CD, we can add these together to find out the second expression for AD, which is going to be AD AC plus CD. So AD is going to be, AC was 8b minus 3, I think. Yeah, 8b minus 3a. And that's going to be plus 3 mu a. Finally, you can write 8b plus 3 mu minus 3a. Okay, so this is the second expression. I'll just obviously carry this to the given space over there. All the things with the drawings are done, so we'll not be going back at the top again. Okay, so this is the second expression and that was the first expression. So we can certainly compare these together. AE is equals to AE, which means that we now have 15 by 4. Wait, sorry, I made a mistake. The bracket should be outside over here, right? 15 lambda minus 6, right? 15 lambda minus 6a plus 6 lambda b is equals to 3 mu minus 3a plus 8b. Yeah. Okay, now we'll start comparing from here. For comparing, we can say that 15 by 4 lambda minus 6 equals to 3 mu minus 3. These are for A coefficients. And for B coefficients, they are going to be 6 lambda plus 8. So 6 lambda equals to B, right? 6 lambda equals to B because these are the B coefficients and these are the A coefficients. Sorry, not B, it's going to be 8. Like the coefficient for B was 8 over here. So which means that lambda is actually 8 over 6. That was lambda equals to 4 by 3. If the value for lambda is 4 by 3, you can apply to the left-hand equation for mu and find out the value for mu. So again, it's going to be 15 by 4 multiplied with 4 by 3 minus 6 is equals to 3 mu minus 3. If you calculate this together, the 4's gets cancelled out, you get 5 maybe. But 5 minus 6 is just minus 1, so you can write it like this. 3 mu minus 3 equals to minus 1, and in that case mu would be minus 1 plus 3 divided by 3. So minus 1 plus 3 divided by 3 is just 2 by 3. So you get the final value of mu as 2 by 3. Now then again, if I remember, the question never asked you to calculate the value of mu and lambda. Maybe they're trying to calculate the value of AD, right? So in order to find out AD, as AD was in terms of mu and lambda, we had to find out mu and lambda. Now after we have the value for mu and lambda, I can just use this and input this into any of the equations to find out the value of AD. Now I'll obviously use the second expression because it's much more easier. So at the very end, I can finally conclude and write the final expression for AD. That was AD is equals to 8b minus 3 mu minus 3. So you have, sorry, it was plus minus 3a. The value for mu was 2 by 3. So it's going to be 8b plus 3 2 by 3 minus 3a. If you calculate this, it's going to be 3, wait, 2 by 3 minus 3. That's going to be negative a. So the final value for AD is negative a plus 8b. Right, so this is how the final vector for AD would look like. I hope it was all clear for all of you to understand. I'll go over the maths one again. We calculated the lengths for BC using the ratios for BC and OA. Then we calculated OC using this BC, and then we calculated AC using this OC and OA, and then finally we calculated AP using the ratio of APs to AC, and then we move on to calculate OD like OP using AP, and then again OD in using the ratio lambda OP. Finally, we calculate the first expression for your AE using this OP. So using this OD and OA, right? This is the first expression. And for the last part, we use the straight line. We use the concept for straight line that BCD is a straight line, and we use their ratios to find out the second expression. Finally, we compared the two different equations for AE and found out the values for lambda and mu. Then we could have used, mu or lambda, either one of them. I chose mu because the equation with mu was much more simpler to work with, less space consuming. So that's why I used this second equation. And with this, our vectors, this question end. We'll move on to the next one. This one is a very big vector again. This one is from Jan 2022, paper 2. Okay, now again we have, I think we can clearly see they have two triangles, right? OAB and CDEAB, right? CEA. Okay, it says that figure 1 has triangle OAB. They're talking about this triangle. Given that OA and OB is A and B vector respectively, find out AB. That's quite easy because you have this OA, you have this AB, OB, and you want to find out AB. We can clearly see that OA and AB are in the same direction, whereas OB is in the different direction, right? So it's going to be like OA plus AB is equals to OB. So you have AB is equals to OB minus OA. OB is B minus A. Right, so for the final part, AB is just B minus A. And then again it says that point C lies on OA and such that OC and C is 1 is to 3. What it actually means is that this part OC is 1 times and OA is has a ratio of 4, which means that CA would have a ratio of 3, right? And then again, D lies on OB such that OD is 2 by 3 OB. 2 by 3 OB actually means that the ratio for OB is OD is to OB is 2 by 5 or 2 is to 5, which means if OD is 2, DB would be 3. 2 plus 3 would eventually equal up to give you 5. That was the corresponding ratio for DB. Finally, we'll move on. Given that the point E is such that ABE and CDE is a straight line, we certainly are aware that these parts are obviously going to be a very important part of our maths, right? So we'll find and simplify an expression in terms of A and B for AE over here. Okay, so we have to use all these concepts to find out two expressions for AE. Let's see that in how many ways we can find out two expressions for AE. First one is that we can focus on ACD, right? That's one we can use. Another is that it is an extended version of AB, right? ABE is a straight line. That means AE must be mu times AB or lambda times AB. So we can write for part B, we'll just first start with the easiest one, that ABE is a straight line which means that AE is equals to mu AB, and which is going to be AE is equals to mu B minus mu A, right? Okay, so we'll move on. Now we have the first expression for AE, right? This is the first expression for AE. Another expression that we can calculate, we have to use this CD over here. We'll have to first find out CD, and as a ratio of CD, we can express CE, we can use CE and CA to find out AE, the second expression for AE. So before that, we have to first find out OC over here. OC is going to be 1 over 4 OA, right? 1 over OC and OA was 3. Okay, sorry, in that case CA was supposed to be 2, right? Because the total ratio was 3. Okay, sorry, my mistake. We'll focus on in order to find out OC, we can use this ratio over here, that OC is to OA, that was 1 is to 3. We can write this into fractions like OC divided by OA, which is going to be 1 by 3. OA was already A, so we can write OC is 1 by third of OA, which is just A. Now this is the first expression for OC. We'll do the same expression for OD also. We already have this, ratio already packed and ready. So OD is 2 by 5 OB. OB was what? Just B, right? So it's simple. OD is just 2 by 5 B. No more works needed for this. Now we'll directly move on to calculate the length for CD, which is going to be OC plus CD equals to OD, right? So you have OC plus CD equals to OD, where if you focus on CD just, it's going to be CD as OD minus OC. Okay, OD was already, we know, 2 by 5 B minus OC is already 1 by 3A, right? So yeah, this is the final length for CD. We can use this and write CE in terms of CD, so which is going to be CE as mu CD, which then indicates CE as 2 by 5 mu B minus 1 by 3 mu A. And this is the expression for CE. We can now use it to calculate the length for AE, but before that we also have to find out CA, which is going to be easy, 2 by 3A, but I'll just write it down for the record for this writing. So CA is going to be 2 by third of OA. I hope we can understand from that very top drawing over there. So yeah, that's it for CA. Okay, now I'll just take all these things at the very bottom to arrange all these things serially to find out the last expression for AE. Okay, so we'll move at the very top for the last time and we'll focus on, we have CE, we have CA, and we want to find AE. So it's going to be CA plus AE equals to CE, right? So it's going to be CA plus AE equals to CE. So we have AE, CE minus CA. I'll just use this in the bottom space with where all the vectors are written. Okay, CE was 2 by 3 mu minus 1 by 3 mu. So you have 2 by 5, sorry, 2 by 5 mu minus 1 by 3 mu A. And this was 2 by 3, sorry, 2 by 3A in that case, right? CA. So CA is minus 2 by 3A. Finally, you can write minus 1 by 3 mu minus 2 by 3A plus 2 by 5 mu B. So the final second equation for the term AE is now already there. Now we can just write AE is equals to AE, which is going to be AE equals to AE. So you can write the first equation for AE was mu B minus mu A, was quite easy and short. So mu B minus mu A is equals to minus 1 by 3 mu minus 2 by 3A plus 2 by 5 mu B. And finally now you can start comparing. Let me just check for one last minute. Mu B minus mu A minus 1 by 3 minus 2 by 3 plus 2 by 5. Okay, if I just highlight the coefficients of A, this is the coefficients of A, and the other parts are not, the highlighted parts are the coefficients of B. So now we have for A minus 1 by 3 mu minus 2 by 3 mu. Wait, all the things are actually written in mu. Wait 1 minute. Sorry, I made a mistake. The first one was in terms of mu. In that case, the second one should be in terms of lambda. Sorry. Okay, I'll just change it. This is the only part where we need to change. C would be lambda CD, right? I'll just change it over here. These are all going to be lambda. I forgot to use a different constant over here. I was thinking that the other one was about lambda, so yeah, I'm really sorry for it. I'll just change it that very fast. Okay, all fixed. So now you can write minus mu. So minus 1 by 3 lambda minus 2 by 3 is equals to minus mu. And again, if I compare part B over here, it's going to be mu is equals to 2 by 5 lambda, which we can clearly see that a value for mu is in terms of lambda is 2 by 3. We can use it for the expression over here, which is now going to look like minus 1 by 3 lambda minus 2 by 3 is going to be minus 2 by 5 mu. You can just write all the mu together. 2 by 5 mu minus 1 by 3, sorry, mu. This is supposed to be in terms of lambda. Lambda, right? So you can write 2 by 5 lambda minus 1 by 3 lambda equals to 2 by 3, and that is going to be 2 by 5 minus 1 by 3, which is 1 by 15. Lambda equals to 2 by 3. So lambda is 2 by 3 divided by 1 by 15. That is 10. So you get the value of lambda as 10. And for mu, in that case, mu would be 2 by 5 multiplied with 10, which is 4. So you get the value of mu as 4. Now again, over here also, maybe they never try to find out the value for lambda or mu. Over here, they ask you to calculate the length of AE, right? So I'll obviously use the first one, mu A minus mu B minus mu A, which is going to be 4B minus 4A, right? Which is very easy. I'll just write it down over here at the very, very bottom. For the exact last part, AE, the value for AE would be mu B minus mu A, where mu was 4B minus 4A. Right, so this is the final part, and I'll just separate the sections over here by drawing a straight line. Okay, that's it. So this was it for all the calculations we did for this question part B, right? This was just part A was very easy, but part B was a very lengthy process, and that's why maybe they were giving you like 5 to 6 marks for this, right? Obviously worth the mark. We'll be moving on to the last part, last question of this vector view video. This is again taken from May to the 2020 1 PR. Okay, now we have a triangle ABC. This is like a column vector, right? They have the column vector. Okay, this is a column vector. All the vector geometries are done. This is just a column vector. We'll just do this. It's quite easy. AB is this, BC is this. So AB is given, BC is given, where X is said to be greater than 0. Like over here, the BC was actually given in terms of unknown X. And the modulus of AC is already given to you, 5. Now we need to find out the column, AC as a column vector, and show clear algebraic working over here. Okay, so let's first find out an expression for AC, right? That is going to be AB plus BC. So it's going to be AB. So AC is going to be AB plus BC. So AB is 3 minus 2 plus BC is x 5x. So you get 3 plus x and minus 2 plus 5x, right? So this is an expression for AC. Now we can use the modulus of AC also as an equal part. I'll just write it like this, that okay, over here I should just take it down like this, right? Okay, now we can write that modulus of AC was already 5, right? Yeah, modulus of AC was already 5, and we can also calculate the modulus by this 3 plus x whole square plus minus 2 plus 5x whole square equals to 5, and everything under a root. Now I'm not planning to calculate this under a root. I'll just take this root to the right hand side. So I'll just write it down over here for this line, and for the next line it's going to look like 3 plus x whole square plus minus 2 plus 5x whole square equals to 5 square. Now 5 square will be certainly 25, but this 3 plus x and minus 2 plus 5x have to be broken down using that a plus b whole square formula. So we can write 3 plus x whole square, you can write it like this, 9 plus 6x plus x square, and then again minus 2 plus 5x can be written as 4 plus, sorry, no, plus, that's 10 and 20. right? Minus 20x plus 25x square, right? So I can just write these values over there into this given space, which is going to be 9 plus 6x plus x square, and again it's going to be plus 4 minus 20x plus 25 x squared equals to 25. I'll just write everything at the at the left hand side, and I'll just arrange this over here now. You have 25x squared and plus x squared, so it's going to be 26x squared. For x you have 6x and minus 20, right? So it's going to be 6 minus 20, that's minus 14x. And for the constants over here you have 9, 4 and 25, negative 25. So 9 plus 4 minus 25 is minus 12. As we can clearly see, this is entirely a quadratic equation that has been formed, and we have to solve it to find out the two values for x, right? That's 26 minus 14 and minus 12. Okay, so it's 1 and 6 over 13. So it's going to be 26x squared. Okay, so you can write it like 26x and 12x minus 12 equals to 0, where this one should be negative, right? So you can take 26x as a common factor, it's going to be x minus 1, and plus 12 as a common factor, x minus 1 equals to 0, and you end up with 26x plus 12 and x minus 1 equals to 0. So from here you get minus 12 over 26, and the other value would be 1. At the very start they stated that the value for x is greater than 1, right? So you certainly cannot use this one. We are only going for the value x equals to 1, right? So if the value for x equals to 1, the final column vector would be 3 plus x, that's going to be 3 plus 1 4, and minus 2 plus 5 1, that's going to be 3. So let's write it down for the last part, that in that case AC would be 3 plus 1 and minus 2 plus 5 multiplied with 1, which is going to be 3 plus 1 is 4 and minus 2 plus 5 is going to be 3. That is the column vector. Right, 3. So yeah, that is it. We have done all the maths for vectors. We did equal vectors, we did additional vectors, we did subtraction vectors, we did parallel vectors, and we did also completed the all the parts for vector geometry, right? And also the column vectors. I think we did quite a multiple questions for this case. If you still guys have any questions, feel free to ask me in the comment sections. You can also join our batch classes that are open for May 25 and October 24 for this year, and like October 24 for this year, right? The batch classes will be starting from next week onwards, maybe mid-February or starting of March. Right. For any information, you can obviously email us, that is moimahamid at the 01@gmail.com, or you can WhatsApp us. You can find the WhatsApp number in the the description box for this video, and also this entire PDF, the solved PDF and also the question PDF. You can solve this as a worksheet for your chapter-wise worksheets, right? All these things will be available in PDF format into our website and also into our Facebook page, right? So you just search Edexcel Easy Facebook page, and you will go get there, right? Yeah, that is it for all for the entire vector class. We'll in the next start with a different concept which is quite tough for everyone to understand, so we'll start with that. Maybe we are thinking of starting with sets, right? Not sure what we'll do, but thank you for watching for all the video. Please like our videos and share it with your friends for the candidates of May 24 or October 24. Thank you for watching.